nice for you. Today we are going to review part of the coupling cohesion to see whether you understand. Elton? Coupling cohesion, right? So remember last time we talked about coupling cohesion, right? What is coupling? Coupling.
class 里面内部的关系，就是他会不会就是可以单独完成自己的职责，然后不需要依赖其他 class。
Coupling.
就是他跟 class 与 class 之间的关系这样。
Okay, when talk about a type of coupling or a type of cohesion regarding data, is it a data coupling or data cohesion type? We have a type, data coupling or data cohesion. I think, well, this one is the best one, no, probably. It's data coupling or data cohesion.
Coupling, data coupling.
Data coupling. What is data coupling?
就是 class 跟 class 之间，它只有单纯的数据资料的互动而已。
Okay, what is stamp? Stamp coupling?
Stamp 是
More? Jerry, what is stamp coupling? Stamp coupling? Eddie, what is stamp coupling?
Class use data structure be attributes, and data structure can influence other data structure class.
And tell me the difference between data and stamp coupling. They are related to data, right? A difference.
Data coupling use simple data.
Simple? Is that simple? Simple.
Sample.
Sample or simple?
Simple.
Simple?
Yes.
Simple.
Simple type use
Simple
be
type.
attributes.
Simple type. What do you mean simple types of
Like
integer?
int.
Okay. int, right?
Yes.
Integer, string, like that. Right?
Yes.
So we wanted to pass, right? So we have an order, and the order want to know who, who is going to press the order, and then the order want to know customer ID and customer name, right? So customer ID, customer name from customer. Is this data coupling or stem coupling? If ID and ID name, is there coupling or stem coupling?
Stem coupling.
Hmm?
Stem coupling.
Okay, so data coupling, name, ID, name, and we also wanted to know customers' gender, female, male. So we pass all of them. Is this data coupling or stem coupling?
Data coupling.
Okay, and now we wanted to pass not just this, pass ID, name, gender, and pass, I think, favorite foods, right? Or the favorites, right? So we pass this data coupling or stem coupling.
Stem coupling.
Data coupling, right? So because it's quite specific.
Yeah.
Okay, and now we pass this, right? Then we pass another one. Yeah. We have ID, name, favorite foods, and gender, and we pass favorites. The favorites are different kinds, right? Clothing or food, and we pass 5, right? Quite specific. It's data coupling or stem coupling.
Stem coupling.
Okay, data coupling, quite specific, right? Now we pass 5 specific data, to the receiver. The receiver got this 5, right? Because receiver needed. Is this a good design? Data coupling. Sounds good. We say data coupling is a better design. And then I pass this as a data coupling, right? Is this a good design? Yes?
Yes.
What's the limitation of data coupling? Even data coupling is it's a good design. What's the limitation of data coupling? Raise your hand, anyone knows it. Now we talk about data coupling, right? And then we pass, lots of specific data. It might be integer, string, that's very specific. Is data coupling. We said that data coupling is pretty good. Is this a good design? Or do we need to improve this? Any limitation of data coupling? It's going to be hard. This is a good design. Good design. And what I just, anything we need to modify that? Or, we have different kinds of ads. And based on my description, right? If we say that, okay, because data coupling is better than stem coupling. What about stem coupling? That's if we apply the previous description to stem coupling, would it be better or no? If we wanted to convert it or use stem coupling, what would it be? Like the previous, right? Customer and order. We use stem coupling. So what about stem coupling? Raise your hands. Stem coupling. You guys know that? Stem coupling, the same example. If you wanted to change it, you understand that? Stem coupling and data coupling. The same example. If we wanted to change it to stem coupling.
So if we want to change data coupling to stem coupling, we concern about the order. Maybe we pass the whole customer object to another component, and this can change data coupling to stem coupling.
Okay, I just said that we have customer with order, right? And order, order has customers' data. The customer pass ID, gender, right, and etc. Favorites for favorites, anything, and order that is data coupling. But a limitation of data coupling. So if you know it, tell me. And if we don't use data coupling in this example, we change to stem coupling, then we send the whole data structure. It could be an object, right? We send it, and then the customer gets, right? Get everything like that. The stem coupling. So what's the disadvantage of data coupling and stem coupling? Can we use stem coupling to replace data coupling like that? Would that be better? So the previous example, no. Tell me that. How to improve it? So what's wrong with data coupling like that? And what's wrong with stem coupling? No. We can use stem coupling, data coupling. What's wrong with that? Right? Okay, so very not good to use stem coupling, right? Data coupling, is better than stem, right? But the example I gave you, for data coupling, we still can improve it because it's not that good. What's the limitation of data coupling? What's the limitation of data coupling? A very good example. Now you can use data coupling, but it's still not that good. Yes. No one knows that. That's, well, it's data coupling. We can use data coupling, right? But it is not a good design. We can make it better, still get data coupling. If the customer has a lot of attributes, right? If we change to stem coupling, could be worse. Stem coupling, you have a data structure, could be array, it's a lot of things. But a receiver only needs, some piece of that. But you give it order, then the receiver will be hate to receive all the structure. And of course, then data coupling will be better, but data coupling has its limitation. Kevin.
I think some situation stem coupling is better than data coupling is that the stem coupling is based on data structure that contain many attributes of customer, like customer detail, and it only pass once, and another client can take the information he wants in the data structure and don't need to call another class to pass its class because it have its data structure. But the data coupling it need to pass many times because it only pass one string or int.
Okay, so listen what you just described, because lots of bits, right? It says data, right? So, well, we have lots of bits. How many is lots?
Maybe 10 times.
10? No. Right. Okay. So I'm going to give you an example that you can understand that. Alright. So suppose that Kevin, right? Kevin wanted to buy chocolates. Right? Wanted to buy chocolates, not for himself, but he wanted to give it to another one, like probably give it to Elton, right? Elton, do you like chocolate? Yes. Okay. So you like chocolate. Which kinds of chocolate you like? Milk chocolate? You like milk chocolates? like it? Dark chocolate? No, you don't like dark chocolates. Do you like mint chocolate? Almond chocolate? Okay, right, and well, it's not so dark. Well, probably 60%, no, that's a lot of percentage, right? So you like dark, or it's not so light? It's light, sweet, or without any sweets inside? A little bit sweet. Okay, so now, well, I don't like the chocolate like milk chocolates, a little bit like mint chocolates, sweet chocolates, almond chocolates. Well, probably like 2 or 3 kinds of that, or just 2. And Kevin wanted to give Elton's chocolates, right? And he knows Elton's favorites, so he gave Elton's milk chocolates, almond chocolates, mint chocolates, right? And Elton received that. Will be happy to receive what you like. Yes, you'll be happy, right? So Elton received 3 chocolates, and next time another one, wanted to give Elton's chocolates, right? But he has no idea that what Elton like. And go to the post office, right? Post office says, well, you need to put a stub inside a box, right? And okay, presume the person's Charles, right? Charles wanted to Elton chocolates. So, but the box said, well, at least you need to, you get weighted around 10 kilo, for example. Then Charlie buys different kinds of chocolates and put it inside a box, right, and delivers to Elton. Unfortunately, the chocolate has the variety, the flavor, like the Elton, does not expect like a dark. He has dark, or something that doesn't like it. So even there's a whole box of chocolates, different kinds of chocolates, Elton only pick, part of it. That is stem coupling. Okay. Because just it's quite small. It's on sale. Just everything, right? All the different chocolates, packets, right, and standards. But Elton's, Elton's well, part of it. I only need part of it. So here, that's the limitation part of it. If it's a data coupling, usually, how many pieces of the data? 3. Not 10, right? If it's more than 3, it's NG, not good. So you break the good concept, data coupling. And now we have different kinds of chocolates, right? We know that, well, that's better, to let Elton receive it, and he knows it. So presume Elton like 5 kinds of chocolates. Try to separate it, right? So separate into 2 functions like that, right? One is, probably fruit flavored, right? So fruit flavored, and the other could be sweetie, like that, right? So separate, right? And put it one method. It's only has 1 to 3. So if your assignment wanted to implement data coupling, right? A limitation, that's 3, all right? No more than 3. If there's 3, try to separate them into 2 methods. Got it? Let's become 2 methods. Let's data coupling. Stem coupling, is no better than data coupling, but it need to give the receiver the freedom, to do it, because we actually no idea, what the receiver needs. So give you the whole package, then ask, all right, get ID, get something, all right, but no. If the receiver needs lots of bits, we give it a stamp, the whole package. So that's the difference between data and stamp coupling. Got it? All right. Let me change to Edison. What is, we said it's a logical coupling or logical cohesion. The type is logical coupling or logical cohesion. Which one?
X again.
A type of coupling and cohesion. What is as a logical? It's a logical coupling or logical cohesion.
Logical cohesion.
What is logical cohesion?
Class has many logical function.
Logical function. What do you mean, logical function? They belong to the same category or different category?
Maybe the sine, cosine.
The what?
Sine, cosine.
Sine, cosine. Cosine. What do you mean sine, cosine? You wanted to calculate sine, cosine.
And some logical function.
Okay, so is that we have math, right? Math. We wanted to calculate sine, cosine.
Yes.
Okay, sine and cosine. So they belong to trigonometry, right? And
yes.
sine, cosine, right? Tangent, cotangent, like that,
yes.
right? I think that's logical, all right? So usually, if that is logical cohesion, we put that all together, all right? And because logically they belong, to the similar math, but they are different, right? Then if there's a logical, then usually what do we write the code? That is sine, cosine. Don't tell me how to calculate sine and cosine. And tell me that sine, cosine, you wanted to put it, become logical, then what would you do?
I don't know.
What?
I don't know.
Meg? Do you understand the question? It's our logical, right? Logical cohesion. So we need to calculate mass. You understand the question? 我们现在要讨论 logical cohesion. Addison give us 一个例子 Alright. The 例子是 要去计算 sine, cosine, tangent, cotangent, because they are similar. Right? And usually if we write codes by using logical, we wanted to calculate sine or a tangent, then tell me usually how can we do it? Logical. Think about logical. Don't think about the calculation. Right? Logical. Logical
Yeah.
cohesion.
Use if then else.
Yeah. If then else. All right. If and we have sine, cosine, tangent, cotangent. Right. That's. If there is a sines, then do sines. Else cosine. That's right. Or we can use something to indicate. Tell me that combine coupling and which coupling we are going to use in this example. With the logical cohesion. Which one?
We can use control coupling to do that. Maybe we can use, maybe we want to calculate sine or cosine, and we can, if the object we pass is sine, and we just use sine method to calculate it. Else we can use other function to calculate it, like that.
Okay, Tim give you a hint, use control coupling combined with logical cohesion. All right. Zeno wanted to tell me how to implement that. There is the arguments, the parameter. All right. What's up? Gary, using this example, like this.
You say it's like more like use switch and switch the maybe one is the example is 三角函数, right? So it's
Trigonometry, right? And
yes, use the switch, and case one is the sine, and switch, and case two may be cosine, case three is maybe tangents. Then
Okay.
use the function, if the different functions to improvement that. Do you mean that?
yeah. So here we can see that this is control coupling, right? Control coupling. And I just give you the example, there's a logical cohesion, right? So because the example, was given by Addison. Addison said he wanted to, compute the function. They perform differently, actually, but they belong to math, right? So at that, we usually, we use the arguments or parameter, we go to, right? Right. So it combines control, yes, control, coupling, and logical cohesion. How to improve it? Because this is not good, particularly the logical. You said logical, the next one will be coincidental, right? Coincidental, no. See that. So logical, but actually, no, logical, we need to improve that. So, you can see this one. Logical, next will be coincidental. So that's how to improve it. Usually the coupling cohesion, intertwines. You cannot separate it, isolate it. Oh. How to improve it? Really, how to improve it? We don't like this, logical. It's gonna make it very, it's hard. It's hard
Your
to
meaning
maintain.
is don't use logical cohesions to do what?
Yeah. Then, how to improve it?
Functional?
Functional.
Yep.
How to change that? Become functional. What is functional? You just say functional, then you don't know functional. Can we suggest that you go to functional? How to change that? Got it?
Change the functions to a single features, like only calculates the only one's features that is functional.
Yeah.
So make logical to functional is more like separates the features or functions than single and single and singles.
Yeah, that's right. So that could be easy, So from logical, that's not a good design because it is hard to reuse it, right? We give this example, probably we just need to use cosine, right? So cosine, itself, that's functional, but that's only perform the one single function. We don't combine it. It looks similar, but they are different, right? So yeah, you need to understand that. What does it mean for coupling cohesion, and for each one, try to improve it. If it is possible, then improve it to the best one, all right? But sometimes the best one, like functional, right? If we consider the function, but we wanted to downgrade it because it performed better probably, right? We can raise the performance, then you don't stick to function. The functional, means single responsibility principle, right? It's a single responsibility principle. Even though, that's the best one, but, not always. So that's why we have different kinds of ads, right? The poorer, the bats, because we consider some situation, we need to combine them. So yeah, there's a combination of bats, right? So functional is a good one. And mental, all right. Why do we need sequential? Sometimes sequential that is better than function. What is sequential? Need to review, because we already talked about that. What is sequential?
First, result, input, second, first output，就是第一个函数的输出会放在第二个的函数，就是输入到第二个函数。
Okay, and all right. So there's a sequence. All right, there's a sequence. So outputs of the first components, become the second, inputs. All right. Yeah. And here we talk about two. Is it possible we have more than two? First, second, and third. Third pass to third. Second pass to third, and third pass to four. Is this possible? Or only two?
Sorry again.
You just talk about component A. The outputs of component A becomes inputs of component B, right?
Yes.
The procedure, not procedure, sequential. It is possible that the second, outputs of seconds become the third input. Yes or no?
Yes.
And become the fourth. So it is a chain. Right? And why do we wanted to do that? Which one, that's function and sequential? Which performance is better? Functional or sequential?
Function. 你是问我哪一个比较糟糕吗？
啊？
你是问我那个不懂 battery 是什么意思？
I said performance. Which one? So which type? Perform better. That I said perform better means speedy. Speedy.
Function. Functional.
It's more speedy. We wanted to conduct 4 components. So functional, speedy, performs sooner than sequential.
Yes.
Why? Yes. Jackie, can you follow? You understand the question? No. About functional and sequential. Functional, sequential. You understand functional and sequential, right? Which one perform better? Quicker. Which ones? Takes less time. Functional, sequential. These two type. Which one perform or needs less time? Quicker, sooner. Jax, which one?
Is sequential.
Sequential performs better. And which one is easier to be reused?
Sequential.
Sequential is easier to be reused. So everyone needs this and just take it. Functional is easy or sequential is easy. So if you wanted to sell something, you wanted to sell, okay, sell something, then one is that you isolate that you have 4 items, all right? So each item has its price, okay? And the customer can buy any one. It's easier to sell it, or if you buy one, you need to buy all of them. Which is easier to sell?
Functional.
Yeah, of course, it's reusable, right? So when we regard reusability, of course, you isolate that, all right? I wanted to buy the third one or second one, no. Yeah, you can sell that quickly, all right? If you say that, well, if you buy it, that is a group, all right? Like I said, data and stamp, right? I said coupling, data, and stamp coupling, right? Data, I need this, right? Stamp, whatever, packets, of course, you know. So that's the difference between functional, not difference between that. That's the minutes of sequential. It could be very simple 2 components, right? Or more than that, that's sequential. Okay, and Howard, what is procedure? Not that strong, and combine it all together. All right, so that's procedure. All right. Okay, and tell me the difference between sequential and procedure. Which one? No, talk about performance. All right. Which one performs better? I said better is needs less time. Sequential or procedure? Sequential. So sequential. Why? Think about that. Well, a procedure. What do you think about a procedure can transform to sequential or no? Can we convert procedure to sequential? Yes or no? Yes. Why does it say yes? All right. Inputs, all right. So you talk about sequential, right? What do you think about a procedure? Procedure doesn't mean that the first one passed the result to the second one and second. No, but you said we can convert it. So if it is a procedure, the first one, not necessary to pass the result to the second. Yeah, and can we convert it to sequential? Yeah, you said that's probably not, right? So which one performs better? Procedure, okay, all right. So yeah, here's the thing that there's a procedure, right? Procedure that's two component as a relationship, right? Strong relationship because we presume outputs from the first one will become inputs of the second one, and etc. the same. So they become a chain, but it is not for a procedure, right? So procedure, it says not that related, right? So we cannot change that. If we wanted to change it to sequential, probably we have a couple of sequential, different, right? So there are different, but procedure, even a procedure, it says it's worse than sequential, right? So sequential is related, but procedure not that related. But we'll put it all together. That's procedure. Okay, Ian. What about the order of execution? Does it need the order of execution in a procedure? Order. Sequence. So procedure. So we say procedure. It's order. Does order matter? Or procedure. Does the order matter? Do we need to follow order? Procedure. Does anyone know that? Should we follow it? Procedure. Any? So order, sequence.
You mean procedure need to follow the order, yes or no? Yes.
Order is first,
Yes.
second. We got to follow the order.
Yes, yes,
The procedure question need to follow the order.
yes.
Why?
Procedure is like
Yeah.
you always use the functions like maybe 1, 2, 3, 4, and you use it always, and the order is like that. It's the same. You
Okay.
maybe can make it to the